Okay, before the break, we started looking at the syntax for functions. Let's jump back in there. And this is kind of what I was intending to do. This is how I usually teach software development classes, go through lots of examples, very stripped down where we're looking at the bare minimum syntax. And then we'll come back and see it in a situation later. But things were going slow to start off with, so I had to reorganize the original plan and increase the amount of caffeine I drank for the 6 o'clock class. I think it was because I was splitting half the Mountain Dew at 1 o'clock class, then the other half of the Mountain Dew at 6 o'clock, and that just wasn't enough caffeine to start. We've got a lot of stuff covering here, so I'm gonna start drinking a whole Mountain Dew before class. So if I start talking fast, and it's obviously the result of chugging 12 ounces of a soda with lots of caffeine right before class, please feel free to let me know to slow down occasionally or pause. So this method that we wrote returns a value. We ask for it and we get a number back. So then we can do math with that. Print double, so twice as much as 54, and subtract 6 from that. We get a number back, so we can actually do stuff with it. 54 times 2 is 108, subtract 6, we get that. But we're getting the number back. So that's what's known as a return function. Sorry, return method. We can say function in casual conversation, function or method, just whichever one fits better in the sentence. But on technical sense, remember, we only have methods, no functions here. It returns something. We'll see a void method here in a second, but I wanted to, and a void method just does stuff. Return if there's going to be something coming back at the end. In this case, it returns a number, so we can just continue doing math with that. We could return more than one number if we want to. We'll see that here shortly as well. We'll look at a bunch of syntax things. I wanted to take a quick second and point at the debugging tools. We have this green run button, and hit that, and it runs through all that code really, really quick. And we can look and see if the values are right or not. But notice there's nothing in the variable explorer for in Spider. It doesn't have any variables we can look back at. And that's because the only ones we had were local. When we created this parameter, that's a local variable. It only exists in the scope of that method. And when that method's finished running, Python has really good garbage collection. So garbage collection will clear that out of RAM when that method is finished running, so that we're not wasting RAM. And same thing with this one, it only exists in this method. So to see those, if there's an error and we need to track it down, we won't be able to see the value in the variables, local variables afterwards. So it seems like a good place to introduce debugging tools. So instead of the green run button, we have the blue run button. And there are lots of debugging tools available. Whatever IDE you're using to write code in, probably have debugging tools. Unless you're in the bare minimum, like you're typing your Python code in Notepad and then running it from a terminal. All you have there is the error messages. But if you're in anything that could be called an IDE, you should have some debugging tools. I don't know if anybody's using idle, but for idle, it's right up here. You go to the debug menu and turn on debugger, and probably stack viewer as well. And then all your debugging tools pop up whenever you hit a run on the program. The debugging tools pop up. Zoom's behind the way. But here in Spider, along with that green run button, we have a blue run button, the debug button. So this run's a little bit different. Notice when I bring my mouse over here, I'm getting all these little red dots beside the line. So that's for setting a breakpoint. So if I come down here and this just gets that ready to run, it doesn't actually run it, just getting prepared to run. We don't actually run it until we get way down here inside our card. So I'll put a breakpoint right there. And what that does, when you click that red dot, when you hit the debugger, it pauses when it gets to that line. So it hasn't ran that line yet. So the first button will step to the next line. It's like, okay, run that line, go to the next line. In that case, it ran that, called that method, did all the calculations, returned 8, and then printed that out. And the next one, so that runs one line at a time, run, you hover over it, you can see what it does, run current line. And the next one, if we need to actually step into a function, so like in this case, if we wanted to actually run that function, or if we're in the middle of a function, we have step out of a function. Where'd my hover go? Oh, there we go. Step into or run until the something returns, or the looks like a fast forward button that just jumps to the end after we're finished looking at things. And that gives us the ability to run our code one line at a time. So we saw that first time, I just hit step and it ran that line and then printed out the result of it. Maybe we want to see what's going on in there. So if I have to do step into, you see now we're looking at this line of code. We haven't run it yet. We have our parameter. So the parameter X received the value 18 because that came from the previous line of code. So when we hit step, and if we go over here to the step button, we'll run that line and it moves down and the blue arrow points at what we're ready to run. We're ready to run the next line. So if we run this line of code, see now we have values for D and X, those local variables, and we're ready to run that next line of code. So those are some very, very useful tools. You'll want to start with those first three, the basically blue run button instead of the green run button. The step runs the current line, and the step into runs current function. So when we hit return, step will run that. It jumps over here, and then this is where the print method's defined. So it's going through the steps of running the print method. What I'm doing here. Because I stepped into a function, I haven't actually stepped out of the function yet. But there's all the stuff we need to see. Someone skip to the end or stop it, will kind of stop it along the way, close that extra file from the language that opened up. But that's really useful. You want to get used to start using those tools. When you hit a problem, don't just look at your code, try to run in that debugger just to practice the tools. Even if it's something that you obvious, like maybe there's a typo right here. Well, that's not going to work. All the typos springing to mind would not let me run it to begin with. I was trying to think of a typo that would still run, but even if it's a typo and you can see where it's at, try running the debugging tools. That makes it even better practice with the debugging tools and getting used to those. Because as your programs get bigger and bigger, those become more useful. And track what's going on in the program at every step along the way compared to what you think should happen. So our main two types of functions, we have a return method, and then we have a void method that just does stuff. It doesn't return anything. So like define, I'll do this so I can tie them together. Triple, which again is going to take in a parameter, the number we want 3 times as much of. I'll say P equals X times 3. And this time, instead of returning that value, I'm just going to print it to the screen. This is one that often confuses people because a print is not a return. Because where does a print go? When we did a return, like down here, it just sends that number right back to where it came from. And then we put that in a print statement. And the print statement goes to the unit. That's output. So a return has to go back to another code. That confuses a lot of people at first. When we actually print, the output does not count as a return. Because we're not talking about returning it to a human. We want to return it to another piece of code to do something with. A good example is, well, I'll do that a couple times. So print triple, actually I don't have to print, it's not returning anything. Actually, I'm going to print triple the number 3. When I run this, so there's 3 times as much as 3. It printed it out, but notice it does return something. It just doesn't return a value we can do anything with. Because it printed out none. That is a specific type of thing. The only way we could really have nothing on an electrical machine is to unplug it and turn it off. There is electricity that makes up nothing as far as the program is concerned. So that's what gets returned in a void type. It does actually return none. But we typically wouldn't do that. We'd just say 333. And then the doing stuff is going ahead and produce some output from that method. Then we don't need to send anything back to where it was called from. A good example in the difference between them is we could call triple, and then to fill that parameter in this method, we could pass in something from our other method. So this one would run first. We call the double method, which doubles the number we pass in. A very trivial example, just so we can look at the pure syntax by itself. And then that doubles that number, so it turns that 5 into a 10, sends the 10 back, and then we'll pass the 10 into the triple method. But that would not work the other way, right? I'll print them both up. Going the other way would cause problems. If we tried to double the triple method, only one of those will actually run. Because when we go pass that 5 into triple, it finds 3 times as much, so 15. Then it prints that out, but then it returns none. So twice as much as none is meaningless. It should be a logic error. Let's run it and see. Yeah. Twice as much as nothing is an error. And it doesn't even make sense to say that. Twice as much as none is just a problem. But it's interpreted language, so everything before that line should have run. Yeah. So 3 times as much as what we get from the double method does give us a number. But the triple method prints out the number that it finds and then returns none, so we just get an error from that. What's it say? Unsupported operand type for asterisks and none. So we can't multiply none type. And James is looking at the screen, so let me move some zoom thumbnail so you can see. That error message does specifically say none type. So none isn't nothing, it is a data type. It's not emptiness. It is a data type, just like our integers, our strings, our booleans, and we'll make our own data types before long. That will be important later, but just be aware that it is for now, or that it throws a type error. We have the wrong type of data. So I'll comment that out and put it. Does not work this way. That seems a good example. We can do more than one return. Let's make another one double, triple, define increment up to quadruple. So we pass in X and then double is 2 times X. Triple is 3 times X. Quadruple is 4 times X. So now we have a whole bunch of values that we might want to return. And because we're walking up along the way, this is what the range function does, basically. Range function does it much, much better. Range function was written in C++. So it's really just a special word that Python recognizes, the Python interpreter recognizes, and calls some C++ code. That way it'll run really quick. But here we have multiple values, and we'd probably like to get all of them back. Oops. So we haven't actually seen it yet. But we can return all of them as a comma separated list. So I'm gonna go ahead and return 1 times as much as, since we have double, triple, and quadruple, might as well return the original as well. So XDTQ. Oh, I missed a comma. Comma. So a comma is separated between each one. So now when I print that, print, I'm not going to try to type that again. Copy and paste that with the number 4. Does anybody recognize that return type? So notice how it sends us back some numbers, comma separated in parentheses. The parentheses are the important part. So 3 on the Zoom call should recognize that data type because we used it a whole bunch the last 2 weeks in the game development class. It's like an array. So that one's what's called a tuple. It's an immutable array. We can't change it. So the starting point for when you use those is, you can think of it like security. It's an array, but we can't change the data in there though. If we wanted different data in there, all we can do is make a slightly different copy. But we can index it just like that array. So I'll assign it somewhere for instead of printing it. Instead of printing it, my tuple is all that. And we'll talk about them when we talk about arrays. They go together. It's just that arrays, we can still change the values, and then we can print the things from there. So my tuple, I'll just print the whole thing. Print my tuple index number 2, or print my tuple index number 1. And we use square brackets to ask for a particular element, just like an array, but we can't change it. If I tried to change it, so like say my tuple index 0 equals a 4, it's not gonna like when I do that. Oh, it is a 4. Equals 5, it should throw an error on that last one, yeah. Tuple object does not support assignment. So if that was an array, we could change that first element. We'll talk about arrays soon, but y'all would have seen them in the last class. And it's an interpreted language, so it did run up until then. Let me run it without the error though. So there's our whole tuple, and we have an index 0, index 1, index 2. There's a slight discrepancy. We ask for the beginning and count from the end. And so if we go with the simple binary code like we talked about, the integer 4 is going to need at least 3 bits to write. So we ask for bit 0, and we need bit 1 and bit 2, but we don't count it as we have the integer 4 until we have enough bits to represent 4. So that's where the indexing starts at 0 because we ask for the beginning of that data. But it's not our first element until we have all the bits that make up that integer. So we have a discrepancy. So we would say this has 4 elements, but those elements are 0, 1, 2, and 3, because we have to ask for the beginning or where that data starts. We'll talk about that in arrays, but the thing to notice is if we have if we want to return multiple values, it comes back as a tuple. Then we can just index them about that way.
Question, please.
Yes.
Is a tuple the same thing as a range? Where you have a tuple, increment quadruplet, is it the same thing as range?
Oh, range is a very special one. Range is a very, 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 in the background, what's happening in the CPU, range is very, very good at what it does. But yeah, that's what's going on with it.
Yeah.
It was all those numbers. If that helps to think about it. I just wanted to, numbers seem like a nice simple example here. we have multiple returns, we get all of this. So in our payroll calculator, we could figure out all the numbers. I guess we need 3, right? List out to confirm everything on the check, the hours worked, the rate of pay, the gross pay, the net pay, and the taxes deducted. So we could just write a method and return all 5 numbers and then index them from that tuple, instead of doing them in different methods. Different ways to write our code. Cursor was in the wrong spot. The other thing, and this gets into the point that was kind of skipped earlier with object-oriented stuff, and why we need that guard, why that's so important down there. We only run this if we hit if it's called main. So let me look at the debugging tools in idle. If I go over to idle and open this same file up, so I'm going to delete. I'm pretty sure I can find the same thing as Spider, I just don't know where it prints out. So I grab my methods, turn on the debugging tools, and then come over here and hit run. Notice what it's running. It's not running a file called mymethods.py. It's running a file called __main__.py. So it renamed the file we actually pushed the run button on. That's what that can do. That selection structure is checking for. So we only want to run our code, this part down here, if we're in the file name main. And the reason we would do that is usually we generalize these things. We generalize them, make them generic so we can reuse them in lots of different places, not just the current program. And that's something you all have done repeatedly. Let me create a new thing here. I'm gonna go ahead and give it a name so I don't forget to, I'll call it use my methods. So what I'm gonna do is import my methods. And now we can call all those methods. So print double with 14, or call that triple method, which isn't quite right yet. We'll see the error message. But over here where they're defined, I can ask for them directly. I'll type the rest of that in a minute. But notice that double, there's an error on that line. And that's because it's not in this file. That's what the import is. So anytime you import something, you have a whole bunch of methods and other things written in another Python script. So we're asking for those, so we could say import. So when we want to print from that my methods module, that's how we often say it in Python. You also hear it referred to as libraries or packages. We call it different things depending on the language, but where we define all of our code, where we say what that method does, is usually different than where we use it. So like a library of things, a different package. In Python, we use the word module. So it's in a different module, so we import that module, and when we bring it in, it comes in as an object. So we can refer to the object we brought in, and then dot one of the methods written in that other module. And we can rename it, methods as MM. So that since my methods is a big long thing to type, we can abbreviate it. So as is just sort of like a reassignment. We put it in a variable that makes it easier to name. You can also do that. Let me also do this. Oh, I got the MM. So notice the one on line 13 we're filling that parameter, has parentheses. But the one on line 15 only has the name of the function. So if I run these, clear all that stuff out, clear the console, and then run that. There's one of them, the one with parentheses, that went ahead and carried out that action. But the other one just tells us we have a function. So it's almost like using it as a variable. That variable is storing a function. It's called double, and it's at this location in RAM. So it's telling us what it is, but not actually running it. So there we could use it to rename things. Making it easier to type. So like P equals double or mm.double, and then we can print D with 3. So notice how it's easier to name it in our code when we need it. So don't shy away from long descriptive names that are very, very clear, because you can rename them, do quick abbreviations when you need them. Typing's easy. Don't be lazy with typing. Spell the names out, make it clear what they do and all of that stuff. But notice how we imported that and then we were able to use it. If I go back over to idle, which I probably should have just left open because I know I was getting ready to do this. And I open that file again, or the one with the import. I'm going to turn on the debugging tools and run this. So it still ran something called main, and we're up to line 2, and there's all sorts of stuff on here. Let's expand it here. Close that and auto stack. So I'm going to open the stack and turn on debugger, just since I'm here in idle to look at it. When I run this, it's running this file named main. Oh, the stack's only going to open if I hit an error. I'll come back and open the stack. And here, instead of figuring out which arrow is which, it's actually spelled out. So we can step and run the next line of code. So now we've imported that, imported my methods as in internal stuff, internal, do a bunch of internal stuff, but eventually we'll have that brought in, and then we have the my methods. So an error, it should open the stack here. Oh, we hit a warning, not an error. But notice that the file we actually ran, something else was named main this time. And then that main received a module. So that's what that guard statement was about. That's how we know we're in the one that we hit run. Because if you just put a method that ran all those at once, like if we just wrote all that stuff and then started calling them right here, 111, 222, that'll work. And this big one, this big name for 3, when we try to import that, that stuff automatically runs. We can't stop it from running now, because we imported that module, and part of that module is automatically running. So that's what that guard statement is for. It prevents us from automatically running things. Like, we doubled. I guess there's no, we should print some of those. These two need printing. Print that one. Whoops. There we go. Keyboard wasn't cooperating for some reason. If I print that out, it'll be a little ice. There we go. So notice we couldn't stop from running those things we imported. They run automatically there. If we come over here and hit run, those lines of code built that aren't inside of the guard automatically. So whenever you put your stuff together actually do your test cases and call your main and everything, make sure you put it inside of that guard statement. Otherwise, anytime you try to import it and use it somewhere else, let me just comment those out, which I think is for one, yeah. I'll just comment them out because anytime you're going to use them, you probably want to use the method someplace else more than just the place you wrote it in. So you don't want them to automatically run. So put out your test cases inside a guard, or in general, even what I did here, actually using it would probably be bad form because we've talked about a guard. So all of our code should really go inside of that guard, or where we start running the code should go inside of that guard statement. And now that we've talked about it in class, and I already marked attendance for today, it was perfect attendance today. I'm going to start expecting to see that on your homework. So make sure you put all of your code, put the if name equals main in all your assignments. Get used to it. I think the book skips over it to try and keep things simple, but we've talked about it and it's not very complicated. So make sure you put that line in all of your stuff. Which the easiest way to do that, really, if you're using Spider or Idle, any IDE would have this. If you go to Tools and Preferences, under Editor, you come down to the Editor option, and Advanced Settings right here is where you edit the template for a new file. Just go ahead and put your guard in the template because you know you're going to need it. Let's add something to the template. So, whoops. So now that that's open, I can just come down a little ways and write if the name equals the main, then print ready to run this. Ready to run, that sounds good. So that's just part of the template now. Wait, was there an error? Oh, 2 equals. So I'll save that. And now every time I hit the new button in Spider, I already have the guard there. That's what the templates are for. Make sure you take advantage of stuff like that. Then you only have to type those things once. Computers never make typos. That's a human trait. Take advantage of the things like templates and stuff like that. Is that everything I want to talk about with methods? So we have return methods, void methods, multiple returns. Oh, should probably talk about global variables. I'm going to call it import and stuff because we want to use this everywhere. 8. Oh, 42. We have this important stuff. This variable is going to apply in lots of places all across our program. So we might want to use that in a program. So I'll define a method called uses important. And here, I guess I'll just print it out, print important stuff. And so notice I'm accessing it. Well, yeah, I'm asking for it. I need to do stuff with it, or that'll work, yeah. And notice there's no clear end to the block. Something that can be useful is add a comment at the end. In C family languages, we often add comments at the closing curly braces. The opening curly brace is right by the name of the method. So those are easy to spot. The closing one might be many lines away and have a whole bunch of other curly braces and stuff down there. So they're easy to get lost. But we can do the same thing in Python. Come down a couple lines and just write in use is important. Those are useful comments because with that significant white space, sometimes it's hard to tell when we hit the end of a function. We just add a comment down there to make sure it's clear where it ends. But if we run this, oh, I should call that somewhere. Uses important. When we run that, you see we can access that variable fine. It has global scope. We defined it all the way, no indenting. So with Python, think of the scope as the indentation. So if it's at the same indentation level and we haven't undone the indentation level, that's all that variable will exist for. So something all the way over here, no indenting whatsoever on it, we can access that anywhere in the program. Because all of the further layers of indentation have to come after it. But like the D here, it's in an indented level. So once we hit a spot where our text is non-indented anymore, we can no longer access that as small scope. So we can access that variable, but if we wanted to do something with it, define changes important, and we wanted to try, maybe say important stuff plus equals 3, we hit a bit of a problem. Notice the error message. It's not going to let us run that. And the reason is local variable important stuff is defined. So it thinks it's a local variable now. It thinks that's our local one. And the reason is we're doing that, we're trying to change the value. So if you want to access that, there's two options. One of them would be to pass in a parameter like we did up here. And the other one is to use the keyword global. So if we use that keyword global, then it knows we don't want the local version, we want to change the global version. So we can read it, but we can't write to it. That's the two things. So if we have global variables, we have read access to them from anywhere in the program, but we do not always have write access to that variable. So that keyword global gives us write access to that. So if I come back over here and say change is important. So now it's changed, and then important stuff. Notice how I just accessed it directly. Those who've seen object-oriented programming, that should look a little bit familiar. That's a variable over in the other program, and I just accessed it directly from right here. So when we import a module, it comes in as an object. So that's where we, in Python, that thing I was saying earlier that probably didn't quite seem right from the code you've typed so far, we only have object-oriented programming. Oh, whoops, I meant to print that. I guess it doesn't do a lick of good just to type the variable's name there. So if I print it so we can actually see it, there we can see the change afterwards. So that earlier one uses important, that prints it out. So no need to print it twice. And then we changed it and then printed it again. I guess I could have done the uses important method. But the thing is, the read-write access is not consistent. We always have read access to our variables, but we do not always have write access. Throwing that keyword when you're doing functions to do those. And that's all the list of the function syntax. The quick stripped down version, right? The book has examples. I'm getting ready to put in an example. Hopefully it's only gonna take a couple minutes because it's copy and paste just to clean up that thing, that payroll thing. But see how we're getting, this is how most of our class examples are gonna get. It's kind of a slow start, but just the most stripped down basic things, basic stuff we can ask the programmer to do so that we can focus on the syntax. And then that, what I feel, or what I often call the standard Python syntax. Keyword, the situational unique portion, a colon, and then indent everything that goes with it. That's the standard Python, what I call standard Python syntax. It'll make a big difference on Wednesday, because when we're writing files, our textbook just shows something that does not follow that, and is actually not a very good way to write files, because it lends itself to errors and mistakes and leakage. Our code could leak over into other things with. So I was just going to avoid the leakage altogether and show you the way I write methods or write files. But that's for Wednesday. Does anybody have any questions about the basic syntax there for methods? Hopefully it all makes sense. And well, we can do this part later. We're less than an hour of class, and it's an active subject we learn by doing, so I want to make sure there's time to do. But then this could easily be cleaned up into methods. We are going to do it soon. So this example is on GitHub. If you weren't copying along, for this is FA version. This will be on GitHub in a few minutes. But think about how this would best be put into methods, how to modularize this code. So like here, the inputs, those all go together. Right? So we're probably going to make an input function define get input. I guess we'll go ahead and start doing some of the stuff like that. My thought was, well, kind of right where the spaces are. And then the selection structure, that's all our calculations right there. So we can make a function that does the calculations. Let's put that up into modules, which is just copy and paste. So I guess I was going to say, think about it and we'll do it later. But might as well do it because it's just copy and paste. So like get inputs. We don't need to do anything. We're just grabbing some variables. So let's copy this, and then I'm going to push Control. Whoops! While it's highlighted, push Control-1 to comment it, and I'll write all this code up here. And then return those values. So employee name. Oh, I guess this is a little different than what we saw. Hours worked and rate of pay. So instead of returning one tuple, I can go ahead and make a list of variables to put that in. And if we come up here and say return all three of these as a list, which the names do not have to match. Let me change that even. EN, HW, ROP. That way the names do not match. The computer will never get them confused, so it would be okay if it's better if they match, because then it's easier to tell what goes with what. But we return three values, so we can make three assignments at once. So those three variables are going to be that get inputs function. And there's a use of that stuff that we just looked at the basic syntax for. I guess we didn't really see that one earlier, but does what's typed there make sense? So when we run it, it should be the same. So it's going to ask, who are you? Sally. Sally makes or work 34 hours and makes $12.34 an hour, and there's Sally's pay. And the other part we haven't moved up method yet, but it still behaves exactly the same. So it works. So can take out that middle part I'll save as. I'm gonna make this 10200 now. Because that's a big change. It's not just a little bit of shuffling around for that while loop, we're actually modularizing this count. So that's like the next version. So, okay, that stuff, moving that over works, so now I'll delete it. And always do that, always comment and then delete. Never delete immediately, because you might need to get back to the last thing that worked. So comment out the stuff you want to change, make sure the change is good, and then do another, and then recreate it. I guess the next thing is we need to, and we are in an interpreted language, so the order matters. We have to define that before we ask for it. That's why I put the function up at the top, because it has to be defined before we ask for it down here. What's next? Calculate pay. So define a function called calculate pay, and it's going to do all of this stuff. And to follow suit, we'll return. I'm going to rename this stuff. So hours work. I'm going to abbreviate it like I did the first time. HW. So another. I think that's all of them. GP. ROP. And TD. So not a very good way to name that. So then we can return those values and kind of change them all. I'm going to keep it spelled out because it looks like a mess there. And I guess that would make better for the example. Let me go back. So we need to return some of those values. So we found gross pay, tax deduction, and net pay. Return gross pay, tax deduction, and net pay. And hours worked and rate of pay we got in our other function, right? So we're not going to ask for them again. We'll need those as parameters when we call this method. And this is the thing that's missing when we look at textbooks. In the textbook, we see the finished example. But notice I'm definitely not writing this left to right, top to bottom. I'm copying and pasting and going through it in the order my mind thinks about it. I think about fixing all that code. If they need to rename, do that, set up the return. And now, the very last step, I think about what needs to go in that first line and the parameters that we pass in when we call this function. So we'll need hours worked and rate of pay. So now instead of having all this stuff down here and comment that out, and instead of doing all of that here, just call that method. We're getting three things back. So we're getting back gross pay, tax deduction, and net pay. And this time I am going to give them the same names. Is calculate pay. Did I put that in a camel case? I did. Our notation this week is camel case. So the very first letter is lowercase. Jam the words together like juxtaposition. And then each time you start a new word, give it a capital letter. This is the one I tend to go to the most often. A lot of people like this notation. As you look at code more and more, then the capital letters where the word starts are like the humps on a camel, and it makes it easy to see them. And in order to calculate pay, we need these two things we found from our other method. So we need the hours worked and the rate of pay that we got from the inputs. Oops. And it should behave exactly the same. Run that. I'm gonna change that earlier version back after class. Stop the earlier run. Okay. Now run the newest one. So we got somebody named Sally who worked 34 hours and makes 34 an hour. Then we get her output, and this time I will go ahead and finish it. No. Oh, is there somebody? Did I do yes and no backwards? Or if next user dot lower is equal to no, then exit the program. I'm not sure what changed there, but this part worked, so I can get rid of that. And notice how much shorter and cleaner the code is getting. I'll leave the outputs there for now. That's how we can clean them up later, but. And if there's problems, we can go right to where that method is. Exit program equal to true. Didn't that work earlier? What changed? So I'll use the debugging tools again. So first thing we do is click here. To enter a breakpoint right before the spot where we're answering question. Then use the blue run button and we can go step by step. So we got all the way up here.
Is your program still defined as true? Is that?
So it starts at false, then not false. And down here, we switch it to true, so not true is false, so we should be done at that point. But we can check here. So we have somebody named Sally, 34 hours, 1, 2, 3, 4. And there's our current values. It's already ran those print statements, so we'll run that last print statement. And then we'll run this line, ask for another user. Type yes or no. I'm typing no. And in the variable explorer, we can say that, see that that's no. So that value switched to lowercase should match this from that line. Okay, that time it did go in the exit statement, so I don't know why it didn't work when I typed the lowercase version. Do the next step. And now exit program is true, so not exit program should leave our loop. I'm not sure what's going on there. I'll look at it. I didn't want to waste a lot of time because that should have. Let me just make some changes so that it actually works before we wrap up this evening. So close that. I'm going to comment this line out. That's the way I usually like to do it. I'm going to make, let's say, next user. Make this variable called next user and start at yes. So while next user all in lowercase is equal to yes. So that's where we start at, right? So just another way to do that. And then we'll come back around and we can probably comment all this out. So we'll get from the user, we'll either get yes or no. We'll type, yes, there's another user, or no, there's not. Let's see if this exits like it's supposed to. So we've got somebody named Sally, worked 34 hours at this rate of pay. Is there somebody else? No. Okay, that time it ended. I'm pretty sure that worked earlier, so I must have bumped the keyboard or something, and I'm just not seeing it. There's more, but I guess that's good for the example. There's more than one way to do it. That seems a nice thing to check. So it only continues if they explicitly type yes. If they type anything other than yes, we'll do that. And see how much cleaner that is along the way now with those methods. And if we hit errors, we can jump right to the method. We have a bunch of small pieces building up our program instead of one big program. It's a solid chunk of code. We have lots of small pieces of code. Makes it a lot easier to debug and track down problems. And so there's the basic syntax and then applying that in an example. So this is the general format I had in mind for class. We were just really slow getting started at it. We'll see that generic syntax, the simplest case, and then we'll apply the concepts over in a situation that makes sense. Does anybody have any questions about those?
Uh,
Oh, that's on the, that was from before the break.
Yeah, I got a question, please.
What's that, Keith?
Yeah, I'm just please minimize that. Okay, yeah, I'm just wondering about the value where you have a Sally, which has the gross pay, the hard work, the net pay, and the next user is no. But the next user has a rate of pay and tax deduction. So where did those value came from? No, hop. Yes, yes. I'm talking about that.
So where did that come from?
Up, yes. Go up. The next
That
the
was
brown,
after
no,
right
no,
here.
the brown side. On the upper,
Okay.
yes, yes. The gross pay, the hour work, and the net pay is for Sally, right?
Yes.
And the next user is no. But the
Yeah.
next user has the rate of pay and the tax deduction. So those two values for the rate of pay and tax deduction, which value did they return?
That right here. So we're only seeing the global ones.
Okay.
So we only see the local ones that were used inside of that method get erased from RAM when we're done. So it's in the return. Remember, if we have multiple returns, it goes into a tuple. But we do multiple returns with a comma separated list. So we can also put that right back into a comma separated list of variables. Real quick here, let me minimize this. And that payroll, when at least was saved on this GitHub one. The other examples I'll just upload manually in a second. But if I go back to the terminal here, change into that folder, documents, the delete folder, and the git stuff folder. Once again, I can use that command git add dot and for the current file, and that will recursively look through all the folders, find all the changes, because we made a couple changes from what it was when we downloaded. Excuse me. We pulled it from the repository, made some changes. So now add dot searches through the current folder, finds all those changes. And if we know those are the ones we want, we can commit to those changes. Actually change them. We do have to include a message. So this was update the payroll example. And now we can see there were 2 files changed, 129 lines were added. Nothing was removed because we adjusted a copy, not the original. That's always good form. It's like, okay, those changes look good, so we pulled from the repository to get it, so we can say git push this origin back on the main branch. We can do multiple branches. And if I jump over to GitHub real quick, and find our class repository, this one, you can see there's those new files. So you don't even have to go to the web browser to do that. We can do it from the terminal. We can interact with this code. Here in our code tonight, I guess it's not in that one. I already closed the other one. We use the import statement. We can import from GitHub. We don't even have to download it. Python knows what GitHub is. There's a couple extra special steps, but basically we can import right from GitHub. We don't even have to download the file and have it someplace close by. We know where it's at on the internet, so then when we make and distribute software, well, those people are going to have access to the same internet we do, that has GitHub on it, so we don't have to send them all of the libraries and that software we wrote. They can just use it right from GitHub and never bother downloading it. Some useful things there. It's more powerful than it's not an online storage. Repositories are way more than just online storage. Change our template, so keep that in mind. Changing templates can be really, really useful. So now every time I start a new file in Spider, it's going to automatically have a guard with a personalized message for me that indicates it's where to start writing code. Or you could just put a comment there. If you don't put anything there, it'll try to say it expected something. So put the word pass there. And that way there's a keyword that's indented. Pass just means keep going. Basically, just keep going. Ignore this line of code. No instructions right here. So you might want to do that in your template. But I'm just going to print a message for mine. So a bunch of syntax stuff. Also on GitHub with the repository, anything we do in a classroom is going to be small. On the web thing here, there's a button to upload stuff. You have a GitHub assignments coming up soon. That's why I went ahead and I'll go ahead and look at some of this stuff. I can grab those 2 files and drag them right over. And we can upload them right there on the web interface, which will work for anything in class. There's a 100 file limit. So anything we do in class is going to be less than 100 files that we upload on any given night. But repository is very powerful. You have some assignments coming up with those soon. If you want to jump ahead, I believe it's in module 6. Take a look and see what the assignment is. Start getting familiar with that. It's a powerful, powerful tool that is used very heavily in software development. So I wanted to go ahead and get started on that. Look at our syntax. And the way we were looking at that tonight, that's the general structure of how the class is going to go. We were a little slow getting started, but it's an active subject. Most of that time, we're writing code and getting familiar with stuff. And we'll look at that, and then lots of tips that I've picked up over the decades of doing this that hopefully you'll remember, you might find useful, or we're all unique individuals, so maybe you'll just completely disagree with me. Maybe you'll just find you completely disagree with me and they completely ignore that tip, and that becomes a tip of what not to do because it confuses you more. Right? We want to learn, figure that stuff out. Whatever it takes to make you a better programmer. I'm going to list off the things that I've found to be helpful over the years. Otherwise, that'll be it for tonight, unless anybody had any questions. Okay, if you do, I'll be sitting here by the computer waiting for questions to come my way for the next 20 minutes. Unless James leaves, because we're the last 2 people on campus except for the security guard. In which case I will probably drive back to Clarksville, so there'll be a 10-minute gap. And might as well if I'm the last person on campus. But anytime you have questions, let me know. I'm always happy to help. Otherwise, I'll see you all on Wednesday and we will get into writing files. So that way we don't have to keep re-entering data every time we run our program. We can save it. Saving is important. See y'all on Wednesday.
Chris, did you get my